Well, here I am, live. And this, I just want to do a little stream in which I show how I do these sprintf replay hacks. So, what I'm doing is I'm adding string logs to NMLGC base TSA thxx stringlogs.version.js. And what these string logs will do is they will make thgrep know that there is a string at that location, and then patches can change it. And the string I'm adding are the format strings for replay names. Now the thing about these string logs is they're not magic. thgrep doesn't magically detect when an instruction happens to use a memory address. That would be pretty slow probably. So what th does is it has these little wrapper functions where it uses detours, win32 API calls, or you insert function calls somewhere in the game's code to call some of thgrep's functions that will check if a certain parameters are, or if certain strings are located at addresses that are in the string logs file, and then use a string from the string from a string defs file if that if there is a matching string at that address, and if not, then it won't do anything and just pass that string. So here is strings via sprintf. Format is equal to strings lookup format. And let's also search for here strings message box A, LP text equals strings lookup, LP captions equals strings lookup, and we also have a create file A wrapper and a find first file A wrapper for that purpose. So how do you actually write these sprintf hacks and find the locations of the replay name format strings? Well, I'm just gonna open up th17. This is actually the last game I have with which I have to do that, which is pretty awesome because th17 is a game about which I know a lot. So I'll also likely have a lot of things named. Now I don't need that anymore. Let's just go into the memory map, switch to the text section. Now we need to look in the current module for string references, and we will search for .rpy. And as we see, we have the address of a bunch of instructions that push th17.percent.2d.rpy. We care about the location of the actual string, but we only care about injecting code at places where this string is used rather than this one. Because the thing about this string is it gets pushed and then this function gets called, which is my strings find first file A function, which does the strings lookup in order to see if there is a replacement for this string. Alright, now I actually named this soon sprintf. Okay, so when you find this string or an instruction that uses this string, it gets pushed and then something else gets pushed, and the function that then gets called is sprintf. So what we now have to do is change this sprintf call in order to call strings sprintf instead. So let's just do that, but also pay attention to the way the string or the way the buffer in which we sprintf into is used afterwards. Here it is just, here we sprintf into this buffer, and then the address of it just gets put into ECX, and then this function gets called, which takes a string in ECX, probably the replay name, and that's probably some function related to loading or storing a replay. But all we need to do here is we need to replace this instruction with call strings sprintf. This can be as is, and then mov ecx eax. Now this exact bin hack actually already exists in global.js. Maybe I should have opened up everything plus before. Now this exact hack already exists, and it is called, we look into global.js, sprintf replay use ecx2. The 2 was first just used in order to differentiate this hack from another hack with the same name, but now I just say that the 2 stands for the amount of nodes afterwards. Here, as we see, this hack and this one are exactly the same, so I'm just able to take the address of this and then here type sprintf replay use ecx2, and then just say address, paste this in, or paste in the RVA, convert it all to lowercase letters, then write rx in front of it. Great. Now this one is a bit interesting in that it will sprintf into this buffer, but then it won't immediately use that for this function, but actually use it as an argument for this and this function. So what we need to do is we need to put whatever the return value of strings sprintf is, and we need to put it in, and we're gonna put it in here. We can actually put it anywhere, but this is just the best spot to put it in because it's unused after we do that hack. And it's the easiest to and it's also the one that can be accessed using exactly as many bytes for the instruction as the amount of bytes that this instruction has. Okay, we can fit that in nicely. Now since we are going to since we're not going to wait, how do I phrase this? Okay, so basically strings printf as a first argument needs a number. It can be any number. And that number is used to decide whether or not to free a previous thing that thgrep printf or not. Doesn't, but which number we pass doesn't really matter, but we have to pass something. Now what we did before is we just changed the call from sprintf to string sprintf, which, and the number as the first argument that we ended up passing was just the address of what was supposed to be the buffer but didn't actually end up being the buffer. But since we can pass, but it doesn't really matter whether or not we pass the address of the buffer here or any number. So what we can do is we can just override this instruction, and then what I like to do is push ESP because I think that, or I have a theory that when this exact piece of code is reached again under the same circumstances, the ESP value will be the same, and then the 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 previous, and then the th will free one of the buffers it's sprintf into using that strings sprintf function. Now we can call string sprintf, and we have 4 bytes worth of space in order to store the return value. Now we're gonna put the return value into this exact address again, ESP plus 14, which is now actually ESP plus 1C because the ESP is now 8 higher because of these 2 pushes. So mov ESP plus 1C, EAX. And this and the nice thing about doing it like that is that now all we need to do in order for these instructions to use the to use the buffer in which we actually sprintf and not the buffer in which Zoom would have sprintf is that all we need to do is replace a single byte like that, changing it from Leah to Mav. And then we can just put the addresses of these instructions into this list right here. And there is my cat. I have to put it down. Why did we do that? We did do that. Now we can just copy the bytes of this hack and create a new bin hack, sprintf replay reuse 1. Now this bin hack is version specific because it uses a version specific memory address over here. Now the thing is, you don't have to that was just my cat. You don't have to make space in order to fit an instruction to store the return value of this call somewhere in this exact way. You can do it in any way you want, but this is just the most convenient way, and yeah, that's just the most convenient way. And now we just need to copy the addresses of these instructions where I replace the opcode from Mav to Leah, no, from Leah to Mav. And add them here. Now this one we can skip because this is just a demo replace, but theoretically, if you are writing your own patch and you want an amount of demo replays that is not the same as Zoom's amount of demo replays, like you want more or you want less, then you could do something with that. Now I'm not really sure entirely sure how you would do that with this over here. My cat really wants to get onto my lap, but we'll just continue. Okay, now here is also this is one where it actually uses the result from the sprintf in the function call after, so I can just no, the cat is on my disk again. You know what? I'll spend a little bit of time with the cat and then continue working later. I'll also look at chat. Okay, there's nothing in chat. Okay, enough time spent with the cat. Now back to work. So I can just do find mof ecx eax. Now here we actually have 1, 2, 3, 4, 5 knobs, which means that we have to copy this hack, add 3 more knobs, and give it a different name. Okay. Now proceeding to the next. Now this one I already said that we don't have to worry about, but we still need to copy over. I actually forgot to copy over the locations of the string into this file. But basically all you do is you say quote the address, then another quote, then colon, then quote, then a name, and that's it. And if it's not the last line in this file, then you have to also add a comma. But I like to go bruh. But I like to go with the pattern of thxx underscore replay underscore format for the standard format string, and thxx underscore replay underscore user underscore find for the find string for find first file A. But other games actually have other weird things that you also have to add. Okay, sprintf replay use ecx5. I still need the address because forgetting to add addresses is actually my most common mistake here, and it caused people to go into the support channel on the Togo Patch Center Discord server and complain that their game will crash when doing replay related things. Okay, now this one is a bit more interesting because not only is the result of the sprintf used immediately after in the next function call, but it is also used afterwards. But I can just do this. Now this tag is actually exactly the same as this one, so I can copy the address and then just do this. Add the new address, then add a closing bracket. However, I have to admit that this is pretty inefficient, and that doing this on top of that would be a lot more efficient. But there is also, however, what I will do instead in order to keep the file size small is this. So what that I can just do this, copy the address, and then add it to this list. Now here you have to pay attention because not every Leah instruction is created equally. Here ESP, because the thing is ESP plus 8, that's not part of the string, it's somewhere outside that but still on the stack, and this function probably takes a pointer to an int or something, or a reference. Well, the difference doesn't really matter now, does it? Let's actually take a look at this function. But first I'll add this address so that I don't forget later. And also further ESP plus 14. Okay, that's a different sprintf. That's a different sprintf call that I'll have to do separately. This one, the one related to that string. Now I'll take a look at this function of EDIBB plus 8. Yeah, it's just an integer reference. No need to worry about that. And that's another scenario. So ASP plus C. But I'll actually quickly check if that is correct. 14 plus 4 is 14 plus 4 is 8 plus 4 is 1c. This doesn't make any sense in decimal, but it does in hexadecimal. Go check with a calculator. And now I can just say mov here and mov here in order for these two instructions to load the pointer to the correct buffer. Okay, that's different. And this ESP plus 10 is also different. Remember, when you see a stack reference, when you see a stack reference relative to ESP rather than relative to EBP, always check the instructions above and below, because if there are push instructions, then that's not the same. Then here there's this push instruction, and then push ESP plus 10. But this ESP plus 10 is not the same address as this ESP plus 10 because of these push instructions changing the value of ESP. Also, this hack is exactly the same as this one, so I can just take this address and add it here. And take these addresses and add them here. Well, that should be it. Now I have plenty of replays in th17 to test this with. And this doesn't crash, this doesn't crash. Now if I just open up a replay, it cause... No, that's not a crash, that's just hitting another breakpoint. Maybe I should disable all of these breakpoints, or even better, delete them. Because I don't actually need them. Now this is a Zoom bug. Shouldn't happen, but it doesn't happen because of us, or because of me. Now let's check user replays. That seems to work either. Now let's check saving a replay. And watching the saved replay. 0.0%. If you actually pause and save replay fast enough, you can get negative. You can get some pretty weird result. Let me actually check. No, I'm not gonna check. But I think it says something like negative nan parentheses open idx parentheses closed. Now one thing that we also have to check is whether or not saving a replay when beating the game works. Because there is actually different code for saving a replay after beating the game and saving a replay in the pause menu. And I got an achievement for that. Thanks, Zoon. And the achievement. The game is lagging, probably because I'm streaming. Let's see. No. Ah yes, it says that the encoder is overloaded. And the game crashed. See, if I didn't test that, then that would have caused one or the other complaint in the support channel. Encoder overloaded. Small notice about the last line. I'm not sure if congratulation is a word. Wait, I think that the reason why this is actually happening is because it's trying to load a replay and fails. Here, a replay decrypt. Vector constructor iterator. The argument for replay decrypt is the file name. Okay, file name in ESI, ECX. Push off ESI, ECX. Nope, I gotta check the function above of ECX ESP plus 10. ESP plus. I forgot this one. There's supposed to be a sprintf hack there, but I forgot it. Let's see if I missed any use of the address keyword. This is close to 45997A. Yeah, just straight up. Yeah, I straight up forgot these two hacks. Or I just forgot to save. Okay. But I think that this is as simple as just taking this and pasting that here. 59976. The address is there. Yeah, the address is actually here. And yet THCAP failed. Hmm. Yeah, that can also happen. Pretty normal. We will pretend that that didn't happen. So why the fuck does it say negative 0000? Wait, it probably doesn't say negative 0000, but it's probably just the Japanese one. Encoder overloaded. Okay, that's all working. Now, now, now I can just say. Oh wait, I didn't commit that. I forgot to commit that. I also forgot the score files file name. And I also typoed this. Now, as for finding the score file name, all you do is you search for score, and it should say, in this case, the score file name is score th17.dat. You just find an instruction that references that, copy the address of, in this case, a MOV instruction, and then you just add it here. And if I open a new browser window and check on github.com/thpatch/thgrabpsa, here we go, that's the commit. It has our changes in it. And and I really forgot to commit that before. Well, now I did commit it. Thanks for watching.